Okay. Hello everyone, my name is Grant Fisher and I'm here to talk to you today about my master's research project entitled Living Waters, an analysis of the viability of restored streams. This project is it's a cooperation between the University of Tennessee and the Tennessee Department of Environment and Conservation. Okay, before I get too far into my conversation today, I'd like to give you guys an outline of kind of where the talk's going to go and what kind of topics I'm going to hit on in the presentation. First off, I'm going to start off with an introduction where I'll introduce the topic and go over a little bit of background information. Then I'm going to talk about the justification of the research, kind of why it's important and why I'm doing this. After that, I'll talk some about aquatic macroinvertebrates and how they're pretty important for the project that I'm doing. I'll talk about the different sample areas, the different streams that I'm going to around East Tennessee to sample and collect information from. I'll go over the various hypotheses that I've developed for this project. I'll list my objectives, and then describe my methods for you. Okay, so moving right along for introduction. So stream restoration in the last the past decade at least, has become a billion-dollar industry. There's corporations that'll pay huge amounts of money to have agencies come in and restore streams to their former glory, so to speak, restore them back to the way they were naturally instead of how mankind has altered them to be today. Unfortunately, urban streams have had mixed results with restoration. Oftentimes you'll see fish species return and do quite well, but other times aquatic insects will not return at all, or if they do return, they'll be in very limited numbers and only certain species will come back, and I'll talk about that a little bit later. Okay, so for the justification of research, I'll be examining the effect of restored streams on fish and aquatic insects, like I said, and I'm hoping with that information that I'll be able to determine if the restoration itself has been effective. And the reason I'm looking at fish and aquatic macroinvertebrates specifically is because that they're pretty good water quality indicators. EPTs, which is an acronym that I'll talk about just a little bit later, they're different types of macroinvertebrates. They're really sensitive to water quality and different changes in temperature, pH, and if there's pollution present in the water. You can usually see certain species of EPTs or of macroinvertebrates that are present or not present, and from that you can judge how if the water is clean or dirty or whatever. And then finally, like I said, I'll determine if the restoration efforts have been effective. So this is a picture of what a regular stream restoration will look like. Usually the water will be dammed up for a section or blocked off or diverted somewhere else, and the banks will be rebuilt with these large boulders and oftentimes like this gravel over here to rebuild the substrate. That'll help repair the riparian zone and allow vegetation to return, which provides necessary habitat for insects. And then the natural creep or meander of the stream will be fixed back to the way it was a long time ago to help with flow rates. Okay, so I'm sure a lot of you are wondering, what are EPTs? I'm sure a lot of people haven't ever heard that term before, but EPT is actually an acronym that stands for three things. Ephemeroptera, which is mayflies. They're three orders of insects. So Ephemeroptera is like you see pictured here at the top. That's a mayfly. Then P for Plecoptera, which is stoneflies, like you see pictured here. And then T for Trichoptera, which is caddisflies. And that guy's pictured right here, little cool guy at the bottom. And these are by far not the only type or orders of insects that you'll find in a stream, but they're really sensitive to water quality, and that's what changes in water quality. And that's why a lot of people, when they go sample streams, they look specifically for EPTs. They're the most sought after, I guess you could say, because if you can find all three or some of these in the water, that generally means that the water quality is good. But the absence of these could mean that there's something, a problem in the water, like pollution or sedimentation, pH, something like that. So like I said, the EPTs are definitely not the only orders of insects that you'll find in a stream. Another order of insect that you'll find is Odonata, and that's dragonflies. Here's a picture of a typical dragonfly larva. They're actually predators that they'll burrow down in the mud or silt of a stream and ambush prey as it comes along. Another order you'll find is Diptera, which is flies, like this one pictured here. This is a Chironomid midge. They're pretty common in the stream. Another pretty unique order is Decapoda, which is crayfish, like you see pictured here. Now, crayfish, while they're pretty cool to find, they don't necessarily mean that the water quality in the stream is good. They're actually pollution tolerant, which means that they can tolerate some pretty nasty streams. So, while it might be cool to find one of them in the stream, it doesn't necessarily mean that the water quality is good. Okay, going right along, Coleoptera, which are beetles. This is a example of a riffle beetle. They're a type of aquatic beetle that live underwater. That's specific pictures of an Elmid beetle, and they're pretty indicative of good water quality. If you find them, generally that means that the water quality is good and you've got a clean stream. And then finally, another group that you might find are mussels in the order Unioidea. And this is a picture of Velosa iris, which is a pretty common mussel. And mussels are actually pretty beneficial because they'll actually help filter the water. They extract particulate matter and filter feed, and by doing that, they'll help clean the water. Okay, so going along the different streams that I'm going to test, I actually have 9 stream sites total. 3 of those are impaired streams, 3 are restored, and 3 are reference streams. The 3 impaired streams are Upper Third Creek, Upper Beaver Creek, and Baker Creek. The 3 restored streams are the restored section on Third Creek, Beaver Creek, and Williams Creek. It's actually over on a golf course. And then the 3 reference streams are Indian Creek, Big War Creek, and Mill Creek. And the difference is impaired streams have something wrong with them, whether that be some sort of pollution that's getting into the water, excess sediment, pH, like I said before. The restored streams are streams that have actively been restored by some agency, usually TDEC or a different agency like that. It's a stream that's actually, humans have actually gone in and done something to help restore the stream to its natural form. And then reference streams are streams that are basically kind of untouched by man. They're in more rural areas out in the country, and they have good water quality and much higher populations of insects and fish. And each of these sites were selected back last year in a meeting with TDEC. We selected the certain sites to sample based on similar characteristics like stream size, flow, vegetation type, elevation, stuff like that. Okay, this is a map showing the various sites that I've got to sample. You can see most of them are concentrated around the greater Knoxville area, but you've got a couple that are farther away. These 2 up here north of Thornhill, Tennessee, are 2 of my reference streams. It's Indian Creek and Big War Creek. Then coming down here to Knoxville, you've got Williams Creek, Third Creek, Beaver Creek, Baker Creek, and then Mill Creek down in Roane County. It's another one of the restored reference streams. Okay, so some of the hypotheses that I developed for this project. Number 1, I think that excess sediment and embedded substrate reduce the overall stream biodiversity, but restored sections provide adequate habitat and food sources for fish species. And then number 2, the lack of riparian vegetation at restored sites prevents pollution-intolerant EPTs from completing their terrestrial adult phase. So like I mentioned this a little bit earlier, riparian zones are really important for aquatic species. So all of the larvae, all the pictures I showed you of the insects, those are actually the larval forms, and they live in the water where they mature, and then when they become adults, they'll emerge from the water and fly onto land, where they mate, reproduce, and then they'll return to the water to lay eggs, and the cycle repeats. But it's pretty important for them to have riparian zones, which are the vegetated areas on the sides of the stream, to live in, because that's where they'll carry out another crucial stage of their life cycle. And without that, they'll probably not have a place to do that and not survive. And then my objectives and goals for this project. Number 1, I'm going to collect data from restored streams, impaired streams, and reference streams, like I said. I'll collect various habitat information, water quality data, fish samples, and aquatic insect samples from each of the stream types. And then, using that information, I'm going to determine if the stream restoration efforts have been effective and then propose further action. So, good job if the restoration efforts have been successful, or if not, maybe throw out some different ideas of what could be done in the future to help improve them. Okay, so going right along with the methods of this project, the methods are divided into 3 sections. The first part is going to be about fish sampling, then the EPT, or aquatic insect sampling, and then my statistical analysis. Okay, so moving into the fish sampling methods. The type of sampling method I'll be doing for this project is what's known as IBI sampling, and that stands for Index of Biotic Integrity. And basically, the way I do it, I need 3 people. One person uses a backpack shocker, while the other people hold a seine that goes across the stream and lets water flow into it, and in turn, all the fish go into it. So a backpack shocker is what you see pictured here. What this guy's holding. It's basically just a car. It's like a car battery with a transformer on the back that makes electricity into these 2 tongs that you shock fish out of the water in. That's used to record the whole total number of fish species present. We'll shock them and they'll all go into the seine and we'll do a count. And the way it works is there's 3 sample efforts to start. You sample 3 different areas of a pool, 3 different times in a riffle, and then 3 different times in a run habitat. And the way that works is on the last sample, if you get a new species, you have to start over and do 3 more samples, and you keep doing that until you've gotten all the species and you're not getting any new species in your samples. Okay, so insect sampling methods. The insect sampling methods that I'm using have been adapted from the TDEC protocol. I'll be using what's called a kick net to sample the riffle areas of a site, and that's what you see pictured here. A kick net is basically just a sheet of fine mesh that you put in the stream and let water flow into it while another person kicks in front of it. You'll poke both of these ends into the ground and lay rocks on this bottom section of fabric to help maybe make a barrier for stuff that won't get underneath it. So the way it works is one person will stand 1 meter in front of the net while the other person holds the net, and that'll form a 1 square meter sampling area in the stream. And then the person who's not holding the net will kick the rocks and substrate up, and that'll dislodge all the macroinvertebrates that are living on the bottom of the stream, and they'll wash into the net. So when you're done, you'll take the net and wash all the contents into the bucket, which will be picked out and sorted later. The other tool I'll be using that's not pictured here is what's called a D-frame dip net, and it looks just like a butterfly net, but instead of the net being shaped as a circle, it's in the shape of a capital D letter. And I'll use that and take 10 samples from the stream where I'll be sampling. I'll find 10 different habitats that look like they'd have a lot of bugs in them, and I'll just scoop and kind of scrape along the bottom to get detritus and substrate into that. And at the end of the day, all these will be taken back, and all the insects will be ID'd in a lab. Okay, so for my statistical analysis, this isn't a very stats-heavy project, but there are multiple variables that are present in the work I'll be doing. So because of that, I'm going to utilize multivariate statistics. One of the tests that I'll be doing is what's called a PermaNova test, and I'm going to use that to test the effects of restoration on fish and insect IBI metrics. So basically, to help determine if, based on the species that I find of fish and insects in the restored sites compared to others, have the restoration efforts been effective. Another test I'll be doing is what's called a canonical correspondence analysis, and that'll be used mainly with the habitat information from the stream. I'm going to see if the effects of flow and geomorphology on fish and insect IBI metrics has been effective. And by geomorphology, when I'm out in the stream, I take habitat information, basically like the flow of the stream, the temperature, the pH, and if I make note of the habitat on the sides of the stream, if there's been a lot of bank erosion or whatnot, and that goes into play the quality of the stream. Okay, so wrapping everything up with my acknowledgments, I'd like to thank my family for all their love and support throughout this whole process. I'd like to give a big thanks to Dr. Brian Alford, my advisor, Dr. John Schwartz, Dr. Becky Nichols of my committee. I'd like to thank Jonathan Burr and Karina Bynum from TDEC. And finally, I'd like to give a big thank you to all the volunteers who assisted with my sampling. It was a lot of work, and I had to have people come out with me pretty much every time, and I'm really thankful for all the people that dedicated their time to come help. So these are my references. More references. Picture references. And the end. If you have any questions, please feel free to ask. Thanks.